Hello dear friends, welcome once more to another video in our YouTube channel. In this video guys, we shall be doing the correction of the medicine Concour the 2023 guys, the chemistry section of the medicine Concour friends. So friends, this was an exam that aimed at selecting students who are so passionate about studying medicine. So the question comprised of, we have the first section, that is biology. The second is chemistry. The other section is physics, and we have the last section which is on general knowledge. Okay guys, so stick around this video guys, watch the video from start to finish. That way you're going to have access to all the concepts we shall be discussing in this video today. So friends, if you're new to the channel, friends, hi, my name is Omenjo Makarios guys. I'm Humble Mac. So guys, in this channel I bring forth complex science concepts, Concour questions, GC questions, science concept, computer science concept guys. I break them down into tiny bits so that any student across any student now can use these concepts now to better his or her grade in the examination and get into the best school the student desire to get into. So friends, I can only do that if you're subscribed to the channel friends. What are you waiting for guys? Hit that subscribe button friends and stay connected. Press the bell icon to get notified so that each time I upload a video you shall be the first person to get notified. Okay guys, it took me a lot of time to create this video for you guys, a lot of time. So friends, please give the video a like, and friends, let's dive straight into the video today. Okay friends, now let's look at the first question. That was question 51. It was saying that the amount of energy involved in melting a substance without changing its temperature is called the heat of. Okay, so various options. So friends, let's look at the options one at a time. Let's look at the first option. We have vaporization. So friends, vaporization is simply that amount of heat that takes a substance from liquid to the gaseous state. Okay, but in this case they are talking about what? That they are talking about melting a substance, namely from solid to liquid. So vaporization guys is simply from what? From liquid to the gaseous phase, or from liquid to gas. So vaporization is off. Now let's look at atomization guys. Atomization friends simply deals with taking an element, and that's taking an element, right? So friends, for this atomization friends, it simply talks about what? 1 mole of any substance. We aimed at converting 1 mole of any substance now into its gaseous state, but the question does not specify the quantity of substance whose state you want to convert. Okay, so atomization guys is not correct. Note that even if the substance is a liquid, the enthalpy of atomization simply seeks to take that liquid from the liquid state to the gaseous state. But in this case friends, they talk about melting a substance friends, and you know a liquid does not melt. Okay, a liquid does not melt. So we want that substance to be a solid that leads from a solid onto what? A liquid state. So atomization guys is not among. Sublimation guys is not. Sublimation simply seeks to take the substance from solid to the gaseous phase without passing through the liquid phase. For instance guys, camphor sublimes, right? So the change of state from that our camphor, which is a solid, to the gaseous state without passing through the liquid guys is called sublimation. So first, as you all know guys, let's look at combustion. No guys, combustion simply seeks to take that substance from, it can either be a liquid or it can still be a gas in some cases. It can also be a solid. It takes that substance guys from solid. It can produce both water vapor, that is a gas, and carbon dioxide, that is also a gas. So in that case guys, we don't want to take combustion because combustion is like burning something. But now guys, as you all know guys, the reason I skipped D was that D is the correct answer, fusion. So guys, fusion is the right answer because fusion simply seeks to take a substance from its solid state to its liquid state, and that is melting guys. For instance, ice melts, right? Ice melt, and that heat that is needed to change that amount of ice from solid state to liquid state guys is called the heat of fusion. Okay, so guys, option D is the best option for this question. Now friends, question 52 reads that how many grams of calcium chloride, whose relative molecular mass is 111, are needed to prepare 125 mils or cm cube of a 1 1.5 molar solution. Okay, so guys, this question, friends, is similar. In fact, it's exactly an advanced level question, guys. Advanced level question whose that is very easy. Now, guys, let's start from somewhere. So our goal is to prepare what, guys? A standard solution of 1.5 molar, right? 1.5 molar calcium chloride. So that is the goal of this our question. We aim to prepare this standard solution. Okay, now, guys, we know that we can get the number of moles to be the same like what? Moles equals what? Molarity times volume, right? But friends, this particular mole can be expressed in terms of its mass, such as given mass of a relative molecular mass, which is equal to molarity times volume. Now, guys, we are trying to get what? Our goal is to get. So friends, the only unknown in this question, guys, is simply the mass. That is a given mass. So if you make the given mass the subject, you are going to have the mass be the same like molarity times volume times the relative molecular mass. Note, guys, that this our volume must be in dm cube. The molarity must be in moles per dm cube. Of course, the relative molecular mass is unitless. Okay, so in this case, guys, if we plug in all our values, the molarity is 1.5 as it has been given. Then, friends, the volume, which is in mils, we need to divide by 1000 by shifting the decimal place to by dividing this figure by 1000. If we do that, we are going to have 0.125. Relative molecular mass, guys, is 111. If you simplify that, guys, we have an answer of 20.81 grams. Unfortunately, guys, the option is not in this question. Okay, it is not there. So probably, for this was a mistake on this particular question. It was a mistake. In such a case, guys, what happens when you encounter mistakes? You shouldn't bother yourself, guys. Don't waste time on that particular question. Just take any answer closer to it. Okay, even if it's out of it, just take it and move to the next. Okay, so guys, like I'm sorry, guys, this question has no answer. Now let's look at question 53. It is saying that which of the following compounds gives a photochemical smoke of brownish color? Oh my god, guys, when you see this kind of question, no need to waste time, guys. The answer is B, nitrogen dioxide, because it is the only brownish gas amongst all of these gases here. Okay, it's brown in color. Okay, let's look at question 54. Question 54 reads that all but one of the following metallic ions will form soluble complexes in aqueous ammonia. Which one is it? Okay, so guys, this is also a direct question. If you have a mastery of your advanced level work of inorganic chemistry, you should know the only option here is option B. We have the manganese 2+ ion. Great. So guys, that's the only option that manifests. It's a direct question, guys. You don't need to give forth any long explanation. It's simply a direct question. Of course, you know, guys, zinc is a D block element. In fact, whatever is going to give you this result has to be what? Has to be a D block element, and specifically it has to be a transition metal. Note that zinc is not a transition metal, guys. It's not. All right, so option B is correct. So friends, just master questions like this, because you go into the example and you see the same questions like this whose answers are still the same. Okay, question 55, guys, reads that given that the bond energies in kilojoules per mole for the hydrogen for the H to H, for the bromine to bromine, and hydrogen to bromine bonds are 436, 193, and 366 respectively. What is the value for the delta H of the reaction? Okay, guys, so guys, this question is so direct. If our goal is to calculate the delta H of this reaction, guys, when the bond energies have been given, it never means that, guys, the delta H is to be given as the sum of the bond energies of the compounds whose bonds have been broken minus those whose bonds have been formed. So in this case, guys, we can see that the delta H in this case, guys, you can see that which bonds have been broken, guys. The bonds of HBr have been broken, right, to form what? H2 and Br2. So it never means that, and we have two of them here, right? Two of them. So the bonds that have been broken in this case have to what, guys? Those of H2 and those of Br2. So the bond energy of H2 has been given to what? 436, right? So we are going to have our 2 times, oops guys, sorry. So the bonds have been broken, but for HBr, so these guys bonds have been broken, so we are going to take, and since we have 2 of them here, so actually we are going to have 2 times the bond energy of HBr, which is 366. So we are going to have 2 into 2 times this minus bonds have been formed. What bonds have been formed, guys? H2 and Br2. So what are the bond energies, guys? It is 436 plus what, guys? 193. And since the moles here is just 1, so we are just going to have this. We simplify, guys, we have an answer of positive 103 kilojoules. Now, guys, I want you to look at something here. Do you see that the resultant effect of this is that what bonds have been broken, right? And bond breakage, guys, is an endothermic process. So friends, it's an endothermic process, whereas bond formation, guys, is an exothermic process. Now they can be asking you guys that what is the delta H of this reaction? What's the delta H of the backward reaction? The backward reaction is simply the sum of H2 plus Br, which gives you this. In that case, guys, it's going to what? Negative of this same answer. No, the answer does not, the value of the answer does not change, but only the sign changes. Okay, that's it. Let's go to the next slide, guys. Let's go. Okay, friends, the next question, which is question 56, reads that which of the following complex ion does not have a plain square shape? Okay, now guys, I have simply sketched a table here that is going to help you a lot. So friends, now please note this, guys, note it, that the only one that does not have a plain square shape in this case is what? Is this one, guys, the one that have zinc. So that zinc itself is not even a transition element. Okay, so it is the only odd one amongst all of these. So in this case, guys, to be able to know which one has a plain square shape, guys, simply look at the d orbital of the complex ion. That's the last orbital. You need to know that for zinc is fully filled, right? We have 10. So in that case, guys, in that case now, friends, it can never have a square plane shape. Okay, so for instance, simply go through all of this, like what I've written here. We have this one as a place is a square plane shape, and it is normally common for d orbitals, yes, which are not fully filled. Note that, guys, the d orbitals should not be fully filled. That's where your claim should lie. They should not be fully filled. So in this case, we only have the zinc 2 plus, which is fully filled, right? So it has already failed the test. Okay, now guys, so the best option is option C. Okay, now question 57, guys, reads that what property of lithium metal makes it a good choice as a heat transfer fluid in experimental nuclear reactors? So friends, the best option here, friends, is option A. It has a high heat capacity. Now friends, let's look at option B. Option B is saying that high melting point. No, guys, it is not a property that makes it a good heat transfer fluid. It is not, guys. Melting point, boiling point have nothing to do regarding the transfer mechanism of a substance. Now let's look at C. Its non-corrosive nature. No, guys, no. This option C is far from the answer. It's far away from the answer, because its non-corrosive nature, guys, has nothing to say regarding the transfer mechanism of lithium. Keep in mind that lithium is a solid, guys. It's a solid. The D is in that low density. No, guys, no. So density has nothing to do. Then small atomic size, no, guys. So the only option is option A. Okay, now guys, why is option A correct? You need to understand what is meant by the heat capacity of a substance, guys. It's simply defined as the amount of heat energy that is needed to raise the temperature of that substance, that is needed to give it a unit temperature change. So now, friends, if it has a very high heat capacity, it ever means that it can absorb more heat, right? It can absorb more heat from that substance. So that's why option A is the best answer. High heat capacity means that it can absorb more heat. Okay, so guys, that's it. The next question is question 58, which reads that when butanol is dehydrated with hot concentrated H2SO4 acid at 140 degrees Celsius, the product obtained is. So friends, again, I'm sorry, there's no correct answer for this question. I don't know if it was a typing error. If there was supposed to be a correct answer, friends, it ever means that it ever means that we're supposed to have, but let me even see. This is this product is butanol, right? So if there was supposed to be an answer, it means we should have butene as the answer. So the answer is not even here, guys. So friends, let me show you guys what you are to do in such a case if it comes in any manner. When we have butanol in this case, which is being dehydrated in the presence of concentrated sulfuric acid, guys, as a reagent and a temperature of 140 degrees Celsius, what we are going to get, guys, is an ether. Okay, has to be an ether. So it has to what? It has to be dibutyl ether. Dibutyl ether, guys. So this has to be it. If it was a temperature of 170 degrees Celsius, guys, it ever means that we are going to have, but in this case, an alkene, a corresponding alkene, that is butene or but1-ene. Or in some cases, you can see the main product being like 2-butene. Okay, in some cases, it all depends on the condition for that reaction. So in this case, guys, we need to expect an ether being formed. So an ether is not here, guys. Well, let's see 2-methyl. No, guys, these options are not good. Okay, so we need to see an ether. Like I said, guys, if it was a temperature of 170 degrees Celsius, means we are going to have an alkene, such that in that case now, the OH group has to be removed. Not even the OH group, guys. Water has to be removed. That's dehydration, means we are going to remove water. Okay, that's it, guys. So I'm sorry, the option is not here, guys. Let's look at the next question, guys. Let's go. Okay, guys. Now the next question, question 60, reads that for the gaseous phase equilibrium reaction, this is it. Okay, this is a reversible reaction, guys. The delta H is negative 1.6 times 10 raised to the power 2 kilojoules. Now the sulfur trioxide yield is increased by, okay, guys, are the various options. Now, how do we answer this question, guys? When they're talking about the yield of sulfur trioxide being increased, means that we are simply looking for those factors that will favor the forward reaction. Now, since all the reactants and products in this case are gases, it never means that the pressure has an effect on this reaction. Okay, pressure does has an effect on this reaction. Now, guys, let's see. And pressure, guys, only favors the direction with what? With high volume. With less volume, sorry. The direction with less volume. So if you use Avogadro's law, guys, you see that we are simply going to know which one has the highest volume, guys, by simply adding the coefficients of the reactants or the products. If you take 1 plus 1/2 gives you what, guys? Gives you that's 3/2, right? Yes, it gives you 3/2. That's 3/2. Okay. In this case, we have just 1. So 3/2, guys, is more than 1, right? So high pressure, guys, favors what? The forward reaction. That's the formation of what? Sulfur trioxide. Now, guys, let's look at temperature. How does temperature affect this reaction, guys? Temperature is going to increase the yield of sulfur trioxide if the reaction was endothermic. Note that in this case the reaction is exothermic. Why? Because what? The delta H is negative, which simply means that heat in this case is a product. So adding the temperature of this reaction simply means that adding more products. And according to Le Chatelet's principle, it is simply saying that whenever you subject a system to a system that is in equilibrium to a change, guys, the position of that equilibrium, guys, will adjust itself to cancel the effect of that change. So it means that when heat is being produced as a product, If you add the temperature, means that you're adding more products. In that case now, more of what your products now will break up now to give the reactant, means that the position of equilibrium, guys, will rather shift the left. So in this case, guys, what are we looking for? High pressure will increase sulfur trioxide, but guys, less temperature or lowering the temperature will also increase the yield of sulfur trioxide. So A is in that high pressure, that's good. High temperature, wrong, guys. So B is in that high pressure, low temperature, perfect, guys. Option B is the best one. It's the best. C, low pressure, wrong. High temperature, still wrong. D, low pressure, wrong. Low temperature, correct. Overall effect is wrong. E, high pressure, good, but independent of temperature, lies, guys. This reaction is influenced by an increase or a decrease in temperature. Okay, that's it. Question 61, guys, which that the rate constant for the second order reaction 2NO2, which is reversible, gives us that is 2.79 gm cube per mole per second. If the initial concentration of NO2 is 1.05 moles per dm cube, what is the half-life of the reaction? So guys, generally the half-life of a second order reaction is simply given as T1 half equal to 1 divided by the rate constant multiplied by the initial concentration of the reactants. So in that case, if we plug in everything, guys, we're going to have T1 half being equal to 1 over the rate constant is 2.79. Then friends, the initial concentration, guys, is what? Is 1.05. Solving that, guys, we have an answer of 0.341 seconds. So which option is good, guys? Good. Option C is the best option. Now friends, question 62 reads that what is a bleaching and disinfecting agent in chlorine or hypochlorite solution? So guys, the best option in this case, guys, is simply option D, okay, the hypochlorite ion. Now guys, this option is correct. Now why is this our Cl minus not correct, guys? It is not correct because whenever chlorine dissolves in water, guys, if chlorine dissolves in water, what happens now is that the HOCl is produced, and it is what actually causes the disinfection action in any solution that you happen to find itself in it. So guys, option D is the best option. Question 63 reads that what is a pH of 50 ml of solution containing 0.0124 grams of calcium hydroxide, whose relative molecular mass is that? Okay, now guys, let's get started. So friends, to get a pH of that particular solution, guys, we shouldn't forget that there are 2 moles of the OH ion here, right? There are 2 moles, and since this is a base, we have to start by getting the pOH, from which we can subtract it by 14 to get a pH. Now guys, what am I saying? You should know that the pH of a base is given as the pH equal to 14 minus the pOH. But friends, we need a molarity of this solution. The molarity of the solution, guys, is simply given as the given given mass over what? The number of moles. That's the given mass, guys, all over the given mass over the relative molecular mass divided by what, guys? Divided by the molarity. But friends, what is this quantity? 0.0124 divided by 74, guys, is simply number of moles, right? Because moles is given as given mass of a relative molecular mass or molar mass. So in this case, in essence, molarity, guys, is simply given as what? Number of moles over volume. So I have simply done everything at once. This 0.0124 divided by 74 is simply the number of moles. Then 0.5, guys, is the volume. Note that the volume in this case is in mils, which has to be converted to dm by dividing by 1000. So that's why we have 0.5. Doing that, guys, we have the molarity to be the same as 3.35 times 10 raised to the power negative 4 molar. Now guys, how then do we get the pH, which is equal to 14 minus, note that the pOH, guys, is simply given as negative log of the OH concentration. But friends, since we have 2 moles of OH here, so we have to multiply the molarity by 2. So that's why we have 2 times 3.35 times 10 raised to the power negative 4 everything, guys. So simplifying that, guys, give us an answer of our pH being equal to 10.83. So option D, guys, is the best option. So friends, even without solving this question, there's something I want you to know, guys, that option A and option B cannot be our answer, right? Because we are trying to get a pH of a base, and the pH of a base, guys, has to be above 7. Okay, that's above 7 because 7 is neutral. From 7 below now, guys, is an acid. So in this case, the option can either be option C, option D, or option E. Okay, so guys, that's it. Let's go to the next slide. So for the next so guys, the next question simply reads that which of the following molecules pairs has the strongest dipole-dipole attraction? So guys, the one that has dipole-dipole attraction is simply the one that you are going to see the strongest amount of polar bond existing. Okay, polar. So only molecules that show a resultant dipole moment are going to have dipole-dipole attraction occurring. Let's look at NH3. It has a polar bond, right? It's a polar molecule and has a resultant dipole. It has a resultant dipole moment. That's good. But guys, methane is not a polar molecule. Okay, it's not a polar molecule. So option A cannot be our answer because methane is not polar. Now guys, let's look at option C. Option C, methane is not polar. This is not polar. So guys, option C is also not correct. Carbon dioxide, guys, is not a polar molecule. Okay, it's not a polar molecule, guys. It does not even show a resultant dipole moment. It does not, guys. It has a linear shape, so we don't expect to have a resultant dipole moment. Methane, like I said, guys, has a tetrahedral shape. Okay, so the forces exerted by all of them balance themselves, so there is no cause for alarm. Carbon dioxide, guys, is not polar. Methane is not polar. You get it, guys. The option is B, right? I skipped B because ammonia is a polar molecule. Ammonia again is also polar, so the best answer here, guys, is option B. Option B, guys, is the best option. Question 65, guys, reads that if 8.32 grams of methanol, whose molecular formula is CH3OH, are dissolved in 10.3 grams of water, what is the mole fraction of methanol in the solution? Okay, now guys, this question is on phase equilibrium. We need to get a mole fraction of methanol in that particular solution. And guys, to get this answer done, we have to start by getting the number of moles of methanol, which is to be given as the given mass of a mole of a molar mass. The given mass of methanol has been given to be 8.32. The molar mass you simply get it by summing the individual moles that make up this compound. Carbon is 12, hydrogen is 1. So we have 12 plus, we have 4 of this. We are going to have 12 plus 4. That is 12 plus 4, guys, gives us 16. Plus 16 gives us 32. So that's why we have this. Simplifying that, guys, we have an answer of 0.26 moles to 2 decimal place. Then the number of moles of water is given as the given mass, which is 10.3 grams. The molar mass or the relative molecular mass is 18. Simplifying that, guys, give us an answer of 0.572 moles. Okay, now guys, the mole fraction of methanol, guys, is simply given as the number of moles of methanol divided by the sum of moles of the two, guys. So we have 0.26 divided by what? The sum of these two, guys. We are going to have an answer of 0.31. 0.31, guys. This quantity is unitless because we are dividing moles over moles, guys. It is unitless, so we have 0.31. So option B, friends, is the best option. Question 66, guys, states that treating the molecules CH3, CH2C, CH3OH with a strong oxidizing agent will produce, okay, set various options. So friends, please be watchful. Okay, be watchful. We are dealing with an alcohol, and we know that oxidizing different classes of alcohols will yield different products. For instance, if you oxidize a primary alcohol, guys, what do you get? You can either get an aldehyde or you get a carboxylic acid. You get an aldehyde if you use what? A mild oxidizing agent such as what? Such as potassium dichromate without heating. But you can get a carboxylic acid with a primary alcohol, once you use that same potassium dichromate but you heat it, or you simply use potassium permanganate in an acidic medium. Now guys, if you oxidize a secondary alcohol, guys, what do you get? You get a corresponding ketone. But if you oxidize a tertiary alcohol, guys, you don't get anything, because tertiary alcohols, guys, cannot be oxidized further. Note that what helps it to get oxidized is simply the presence of a hydrogen atom on the carbon atom bearing the OH group. So which carbon atom bears the OH group? It is simply this guy, right? Because it bears the OH group as well as a methyl group. So guys, and this is a tertiary alcohol. So since this C does not have an H group attached to it, when you oxidize it, guys, you will not get anything. So the answer in this case, guys, is option E. Okay, so this is simply the compound that exists itself. So that's it. Wait, so you can see that this carbon atom does not have an H group, right? So there's going to be no reaction that's going to be formed. So in that case, guys, option E has to be the best option. Like I said, guys, oxidizing a primary alcohol gives you gives you either an aldehyde or a carboxylic acid, depends on your condition. If you oxidize a secondary alcohol, guys, you get a corresponding ketone. Okay, you get a ketone. If you dehydrate a secondary, if you dehydrate a primary alcohol, guys, in the presence of H2SO4, like we saw earlier, at a temperature of 170 degrees Celsius, guys, you get an alkene. Okay, an alkene is being formed. Okay. Question 67, guys, which is that the name of the polymer formed from the monomer C6H5CH, you have double bond CH2, guys. So this is simply phenylethyne. Okay, phenylethyne, guys. What answer do you have? Okay, now guys, so friends, this compound itself, its common name is styrene. Okay, is styrene. So if you, the polymer of these guys, friends, has to be polystyrene. Okay, so option D is the best option. We have polystyrene. Okay, friends, 68. Let's go to 68, guys. Let's go. So guys, question 68 reads that which of the following chemical substance or entities can act as an acid and as a base? So guys, OH is purely a base, cannot act as an acid. Ammonia, guys, is a base, cannot act as an acid. This H3O, guys, comprises of what? Comprises of the H plus ions, which can only act as a base, and we can only act as an acid. Sorry. Then friends, this our BF3, guys, is simply a Lewis acid. Okay, it's simply a Lewis acid, guys. It's a Lewis acid, so cannot act as a base. So no option, no answer here, guys, is correct. So the answer has to be none of the above. If we had water in this case, if we had water among the options, guys, water would have been a very good example because it can act both as an acid and as a base. Question 69, guys, reads that the number of structural isomers of the alcohol of formula C4H9OH is, okay, so guys, in essence there are 4 isomers in this case. 4. Let's look at the 4, guys. We have this compound, we have this one. When we put the OH group in the first position, note, guys, that they're asking for what? The structural isomers. Structurals don't involve functional group isomers, guys. Don't. Okay, that's it. Then now, guys, we also have the one if we displace, so this is called butane 1-ol. Then we also have, guys, this other. If we put the OH group to the second position, this has to what, guys? This has to be butane 2-ol, right? They are both structural isomers. Then friends, we also have this one if we now try to manipulate now with the methyl groups by trying to link them together. Okay, we are going to have this guy. And friends, this one has the name 2-methylpropanol. Then friends, we also have this one if we try to bring forth all the methyl groups together. We have CH3 into 3, we have COO, we have COH. And guys, this one has the name of 2-methylpropan 2-ol. So guys, we have 4 of them in total, 4 of them. So the option has to be option A, guys, 4. Okay. Oops, guys, this guy was supposed to be here. Okay, it's a mistake, friends. Sorry, this has to be here, not on the 4. It has to be option A. Now, question 68, guys, reads that a molecule is chiral when it's okay. Now, guys, when is a molecule or a carbon atom chiral? Sometimes they call it chiral. It has to be chiral, friends, if there is no plane of symmetry, or if the two enantiomers, guys, cannot be superimposed. That's it, guys. Or if they are not mirror, if they have to be mirror images of each other, right? They have to be mirror images of each other, but they should not be superimposed. But means that you cannot carry one of the enantiomers, guys, and you put into the other. No, guys, no. Let's look at A. There exists a cis and trans isomer. Wrong, guys. This is true for geometric isomers. Geometric isomerism. That's why we have the cis and the trans isomers. Now, option B is saying that contains a plane of symmetry. Wrong, guys. Wrong. Option C is that contains a center of symmetry. Wrong, guys. Wrong. This is not correct. There should be no plane of symmetry, guys. The D part is saying that cannot be superimposed on its mirror image. Perfect, guys. Perfect. Option D is the best option. E is saying that can be superimposed on its mirror image. Wrong. So, friends, option D is the best option for this question. Now, friends, question 71 reads that which of the following cannot be used as a Bronsted base? What is a Bronsted base, friends? A Bronsted base, according to Bronsted alloy, it is simply saying that it is simply a proton acceptor. Okay, a proton acceptor. So, which of these guys can accept a proton, or which of them can accept an H plus? So in this case, guys, the only option here has to be option C. Okay, it has to be option C. Option D, sorry. Oops, guys, this answer is not correct. Okay, please, this answer is not correct, guys. Like I said, a Bronsted base, guys, has to be what? Has to be a proton acceptor. It has to be able to accept protons. So the option in this case, guys, has to be option C, ammonia, please. Okay, because you can accept H plus ions to form ammonium plus ions. Okay, so friends, please make this correction here. Okay, let me see if I can do it for you. So friends, please try to make the correction. So the right option has to be option C, because it can accept a proton. It can accept H plus ions and become NH4 plus ions, guys. Not the answer, friends, is not option D. Okay, it is not option E. Sorry, it's not option E, guys. It has to be option C, friends. Option C, ammonia. Okay, thank you, friends. Now let's look at the question 72. It reads that which of the following substances will also be needed to prepare a buffer using sodium phosphate? Okay, now, guys, to prepare a buffer, what we need, friends, it is simply a conjugate weak acid. That's what we need, guys. That's what we need. We need a conjugate weak acid. And since we are dealing with a phosphate, so the weak acid has to be what? Has to have a phosphate group. Okay, has to be a phosphate group and a weak acid. So in that case, guys, hydrochloric acid is not correct. Ammonium phosphate is not correct. That's a base. Let's see. C is saying that ammonium hydroxide. No, that's a base. Then E is saying that sodium hydroxide. No, guys, it's a base. So for the best option in this case has to be option D, phosphoric acid. Okay, that's be phosphoric acid. Note that we need a conjugate weak acid, and there has to be phosphoric acid that has a phosphate group. So we have H3PO4. Okay, so guys, option D, sorry, is the best option. Now, guys, let's go to the next question, guys. Let's go. Now, friends, the question 73 reads that the element least likely to obey the octet rule in the formation of chemical bonds among the following is... Okay, guys, let's look at the various options: aluminium, Aluminium, guys, is simply a metal and forms ionic bonds, and can also form covalent bonds sometimes that have strong. It can also form covalent bonds with strong ionic character. Let's look at fluorine, guys. Fluorine is a group 7 element that needs to accept one electron to be stable. Nitrogen, guys. Nitrogen is a group 5 element, guys, that needs 3 electrons to become that needs to accept 3 electrons to become stable. So friends, sodium is also a group 1 element. So friends, the best option here has to be option E. Why, guys? So friends, the octet rule, let's look at the octet rule. Is the octet rule, friends, simply states that atoms tend to form compounds in ways that gives them 8 valence electrons, resembling the electronic configuration, guys, of noble gases. So for the octet rule to be satisfied, guys, all the various species must have 8 electrons on their outermost shell, which is similar to that possessed by group 0 or group 8 elements. So friends, in this case, friends, we see that sulfur is the best option. Although sulfur can also obey the octet rule sometimes, in as much as it can also disobey the octet rule, as seen in compounds like sulfur hexafluoride. We have SF6. In that case, the octet rule in this case has been disobeyed, okay, because sulfur, at the end of the day, guys, sulfur is going to have more than 8 electrons in its outermost shell. So first, option E is the best option. Okay. Let's see. Option E is the best option. Now, guys, let's look at the question 74, which simply reads that a gas sample occupies 3.24 liters at 25 degrees Celsius and 734 millimeters mercury. What will its volume be at standard temperature and pressure? Okay, now guys, at standard temperature and pressure, we know that the combined ideal gas equation holds, right? We have P1 V1 over T1, which is equal to P2 V2 over T2. Let's know that they're talking about what, guys, at standard temperature and pressure means that at STP, guys, we simply have constant temperature and constant pressure. If we make V2 the subject, because V2 is our unknown, we are going to have P1 V1 T2 over T1 P2. Now, guys, we should know that at STP, the pressure at STP, guys, is given as 760 millimeters mercury and a temperature of 0 degrees Celsius or of 273 Kelvin. Plugging in everything, guys, our P1 is simply given as 734. Then, friends, our V1 is given as well, guys, as 3.241. Then T2 is 273 over T1 is 298 Kelvin. That is when we convert 25 degrees Celsius to Kelvin by adding 273 to it. Then our P2, guys, is 760. Simplifying this, guys, give us an answer of 2.868 liters. So friends, the best option here that is closer to it has to be option B. Okay, that's it. So guys, that's it. Let's look at the last question, guys. Question 75, which that the region of space in an atom with the highest probability of finding an electron is, oh my god, guys, this question is direct. The best option here, guys, has to be the atomic orbital. So option D is the best. So friends, why is the shell wrong, guys? The shell is wrong because the shell is like a generality, okay? The shell is quite large, it's quite extensive. So in that shell, guys, we have atomic orbitals. That is the exact position in that shell where we are going to have the highest probability of finding an electron. So friends, once you must have passed the O-level, guys, the concept of shell should leave your memory, okay? You should be talking now specifically now on atomic orbitals, and that is simply the definition: the region in the atom wherefore there is the highest probability of finding an electron. That's it. So friends, that's it for the video. That's it, guys. Make sure you give the video a like, guys. Please give a like to this video, guys. It does motivate me to keep producing more great content for you guys. Share the video out with others so you can help them to score good marks in their examination, guys, and to get into their dream college. Thank you very much, guys, and have a blessed day.